Hello everyone and welcome to today's webinar. We will talk about creating an analysis type in line with wishes. You learn the specific way you do cephalometric analysis and you are familiar with measurements, their standard values. You subconsciously know the meaning when you look at the numbers. Cephalometric software should not force you to change the way you do things. It should help you to be faster, more precise. It should help you to do better manage documents, but analysis types which are available in the software usually do not have all the points and measurements, have different standards, standard values, etc. You simply want to have it your way. Unfortunately, there are more than 400 dental schools which usually use different measurements and even approaches to cephalometry, and more than 50 opinion makers who explain their way and approach to cephalometry as well. And some of them are very unique. There are also different races with different physiognomy of the face and therefore standard values. Just a rhetorical question: is it possible to create an analysis types all analysis types in advance? Of course not. So software manufacturers pre-program, hard code or build inside its software 50, 100, 200 or more different analysis types which are more or less similar to what you want. But it is not good enough, So we need to handle this challenge in a different way. This is why Audax decided to create a tool which enables everyone to model her or his own analysis type. Before we get started, a few housekeeping notes. We've taken a screenshot of an example of your site interface. You should see something that looks like this on your computer, and we will also switch on our web camera probably later so that you may see us live, and I sincerely hope that this webinar technology works. I had some problems before, but okay, I hope that it works. Okay, you don't see the balloons. Please pay attention to them. You can change font size through settings button and maximize window and speaker volume directly on your interface. We may change the layout a little during the webinar later on. We would love to hear from you. You have the opportunity to submit text questions to us by typing them into the chat pane on your bottom left. You may send in your questions at any time during the presentation. We will collect these and address them during the questions and answers sessions at the end of today's presentation. This webinar is being recorded. It will be available a few hours after the end of our sessions. Now to presenters, my name is Peter and I will be your host today. Marco is sitting next to me and he will communicate to you throughout the webinar via chat pane, and I will join the conversation at the beginning of Q&A session later. Okay, for those just joining us, welcome. I would like to reintroduce webinar agenda before going on with the presentation itself. We'll be having a good time today. We'll make a mix of slides and software presentations and some questions and answers during and after the webinar. We will first introduce the idea behind AudaxCeph approach. It's very simple, it's brilliant, and we will use very basic elements to build a simple measuring protocol. Then we will show the 3 ways for creating an analysis type, either from scratch or from already existing analysis type, or with the help of a library of elements. We'll quickly finish the analysis type model by adding standard values, reports, layers, and so on. Finally, there will be a Q&A session, but again, I warmly invite you to place questions in chat pane throughout the whole webinar. We are aware that you may have specific requests which may not be covered during the presentation. So ask us, and we can later have one-on-one sessions as well. So we are open to help you. I will run a short movie for you. What you see is AudaxCeph software, and some panels are hidden so that we can focus on creating a measurement protocol. So first thing, I'm going to create 4 points, point 1, point 2, point 3, point 4, and I will connect them with planes which go through those points. And if I move one point, also planes will move. And now I'm going to add measurements, angular measurements, and another measurement between the other two planes. So when I move the points, also the measurements change. Okay, now I'm going to switch on the transparency. So I have a radiograph here, and I will put one point to Nasion, the other to point A, then I will put one to point B, and I will put the first one actually to point Sela Turcica. And I have a measurement protocol here, and I'm going to name those measurements. This one is SNA and this one will be SNB, because I will later need them for identification. Okay, now A and B equals SNA minus SNB. So this will be the third measurement, and I choose a special tool to create a calculation measurement. I define it, and I have right now 3 measurements which can be displayed in a measurement box. I'll double click on that and select SNA, SNB, A and B, and measurement tag, so that we know which one is which. And I will now attach it to, let's say, Nasion point. If I change the position of Nasion or any other point, also measurements change. You can see that it works properly. Okay, now this is not a real life example. So let me show you how a real analysis type looks like. So we'll first look at how tracing with volumetric primitives looks like. So we'll go on, select the patient, use a radiograph, put it on canvas, and use automatic tracing so that all the points are traced automatically. I will save some time doing that. Now I switch on the report layer, and I'll change some things so you can see how fast we can trace. Now I can switch on layers. I have several elements on layers, and I can either switch them on or off. Now I will create a mechanism. Create first the point, then second point, third point. I will connect the first 2 points. Add a parallel plane to the first and go into the third point, and another plane which will cross-sect both first and the second plane. I'll also make a point on cross-section, and that mechanism behaves predictably if I move the planes or the points, so that point is always on a cross-section. Let's make a measurement, distance measurement between the 2 points, and angular measurement. I can change it from one to another angle here. And if I move points, those measurements change. Okay, how would that look on this example with 3 points? So I have 3 points. I'll put one on Nasion, I'll put the second on Sela, and I will put the third on point A. And what I get now is actually SNA angle, and I just need to capture it and put it on the report. So I have here the real life example elements, and this is when I switch all elements on, this is something like this. If I move Nasion around, you can see that all the elements that are dependent on Nasion are changed, measurements change, and it's very important to have them arranged on layers, I mean those elements, so that, for example, all the elements that I need to change for to do an analysis are on the analysis layer, what I want to see on the report is on the report layer, and so on. How to start creating such an example in real life? We suggest that the list of measurement and standard values is made first. Ask yourself if measurements are gender or age dependent. Then we'll do a wish list. So how reports, several reports can be done, of course, will look like both for tracing and measurements. Will there be a real-time measurement table on the canvas? Do we have correlation coefficients for harmony box? Will we need an export to, I don't know, spreadsheet? What will be inside that spreadsheet? What vectors export do we want to have automatically stored with analysis? What kind of automatic superimpositions do we want? So all those answers need to be, all those questions need to be answered. Let us go to the first 2 points. The most important are the list of measurements and standard values, because they define geometry and measurements of the measurement protocol, or speaking cephalometric language, the geometry of an analysis type. There are 3 different ways to create a new analysis type from scratch. Of course, nobody wants to do that unless it's something really new and really different, and we have to do that. What we prefer is to start either from an existing analysis type, in case we want to add or reduce measurements of an existing analysis type, or from elements in the library. Usually we start with this method and model new measurements if they are not already available in the library. In the software, I will create an analysis which has 4 measurements: SNA, SNBA, and BN widths. I will start doing it from scratch just to show how this can be done from scratch, and start again with elements from the library. Now I will close the PowerPoint and go to the software. I will not talk this quickly in this part, because I need to work with the software. I have already switched on my AudaxCeph software, and I'm going to choose the analysis type module. And now I'm going to create a new type. I'm going to name it YYY something. And what I have here is phantom displayed. And here we have element properties. We are going to need that later. First thing is I'm going to create 4 points. This one, here, and here. And I'm just going to name this one Sela Turcica. And the tag would be S. And I will select an image for Sela Turcica, this one, so that it is displayed. I can make a description here, and I can select also a voice, which can be later later used when tracing. So I can do this for all the points. Now I'm going to create a plane from Sela to Nasion, another plane from Nasion to point A, and another plane from Nasion to point B. The next thing is that I want to add angles. So this would be an angle SNB, and I will name it SNB. SNB, and you may have noted that it could be either this or that. I'm pressing the Control key, and another angle is between these two planes, and this is called SNA. Of course, I could choose also Sela and Nasion and A for the angle definition, and the measurement will know that it's an angle between these 3 points. The next thing that I want to do is calculate the A and B, which is positive if A is on this side of Nasion B point, and negative if A is on this side. So, okay, let's put it A and B here, and here would be N. And I use that function element, and I say SNA minus SNB equals actually A and B, and measurement units are degrees, and this is another measurement. So what I have right now is Sela, Nasion, so some planes, some points, and I have 3 measurements here. I want to create another measurement. You see the plane, it's not defined yet. Now I'm going to place it here, and now it's defined, it's occlusion plane, and I'm going to create another plane which is perpendicular to this one and going through Sela point, and the dimension between these 2 planes, I mean between the point and the plane, will give me WA, and this would be WB something. And width is a distance between WA minus WB, it's width, and measurement units is in millimeters. So I have here width which is negative. If I go on this side, it's even more negative. If I put it far away, it's positive. So everything is changing when the measurement is changed. Now I have pretty complex thing here. A lot of measurements is coming and planes and everything, and I need to organize them. So using view tools here, I can hide all the dimensions. I can hide perhaps this plane, and this plane, and this plane, and again this plane, height, whatever, and I will store this to analysis layer. So what I do is store this to analysis layer, and all those elements are going to be stored there. Doing analysis type in this way is very time consuming, so I'm not going to continue. I will use another way instead. So I will create a new analysis. I will delete this one. I will name it ZZZ. Okay, and I will use element library instead. So I have here measurements, points, planes, arcs, whatever, and I'm going to select A and B. You can notice that for A and B I need SNA, SNB, and A and B is a calculated value, and I'm going to find width. I filter that out, and with planes I have Sela Nasion, which is this one. I add this one, and NA, so this is NA and B, and I say okay. So I added those elements to my analysis. Now again, what I need is, I'm going to hide all planes, but I would need occlusion plane, so I go here and I say show it, and I store this to analysis layer. This means that when this is on, analysis layer is on, I need to trace these 4 points and I need to trace occlusion plane in order to get all those measurements. All elements are here. I don't need them. I just need these 4. But what I would like to have on a report layer is separately defined. So I want on a report layer this plane, then this plane, this one, and this one. So this is something that I want on the report layer. So these 4 planes are nice. I can arrange also some text here. Occlusion plane. And the next thing that I need to do is to define standard values. I'm going to save that right now, and the measurements that are being created here, they do not have the knowledge of their standard values. And I'm going to link them to some standard values which can be defined in a way, so I say SNA, SNB, A and B, widths, and for example patient type would be adult. Okay, and I have here 82, that is 80, A and B would be 2, and this would be 2, 2, 2, 2, 2, so not to complicate. And now I can join this to this, so SNA to SNA and so on. But what I can do is also to import it from some standard values that I have in the Excel. So I imported Excel file, and here they are. And I'm going to say SNA and SNA, they are connected, SNB, SNB, and this width and this width, they would be connected. Now, the measurements are aware of their standard values. The next thing would be report. So I need to create a report which will consist of 2 groups. Group 1, it could be sagittal, vertical, dental, whatever. Group 2, I will add those 2 groups. And to the first group, I will add SNA, SNB, A and B, and to the second group, for example, widths. And the preview will look something like this. So we put on the layer those planes, so they are to report layer, so they are shown here, and we have group 1 and group 2 defined as I want. Now everything is great. Now we are ready for the first analysis type. So I'm going to choose the patient and create an analysis. I will change type to ZZZ and run automatic tracing. So the points are put. Okay, I don't have this one defined, but I can do that manually. Usually we define that by putting some points at the end so that the system recognizes. The system recognizes where they should be. We can do some placements. We are aware that this is okay. Now I can create a report. So this would be a report. So have normal values, difference, everything is done. But what I want now is I want to change that a little bit. So I'm going back to the analysis type definition, and I'm going to add interincisal angle. For example, I go to element library, and interincial angle. All the elements are added, and I have them here. And I want to add some incisors. This is tissue definition. I have them here, so I put them aside so that you know what am I doing. If I double click, I just say this one and this one, so for the beginning and for the end, and it's already there. Then I double click this one and say okay, this one here, and it's placed. I can hide that, and I don't know if I need this. I'm going to put what is seen on the screen, I'm going to put on analysis layer so that it will be available for tracing later. Okay, you can check, this one is on layer, this one is on layer, and what is on the report layer? Okay, this is on the report layer. So this is something that we want to see. And I'm going to add also a profile, face profile. Here, and of course what I need is, because there is an interincial angle, I need to add standard values for interincial angle. So I go to link, I say interincial angle, interincial, okay, oops, no, I didn't do that, I'm sorry, no, link, interincial here, okay, and I'm connecting that. The next thing is that I want to have it displayed also here, so I will put it on this report, so we have interincial angle here as well, together with standard values, everything will be defined. Okay, what I want to do right now is define sequential angle, sequential tracing. So I have sequential tracing, and I will choose auto populate, and I will remove this one and this one and this one and this one out of the list. So all those points needs to be moved in order that analysis is being done correctly. We have a silhouette, and I'm going to define also superimposition. I want to have automatically put Sela and Nasion line on top of each other when the superimposition is made, so SN, and I just select here Sela and Nasion and create report. I want to have everything with a scale here on the report. And another thing that I need to do is measurement box. I want to have here a measurement box where there will be SNA, SNB, and ANB. And this one is going to be aligned to Nasion point. So if Nasion moves, that box will also move. And I'm going to create here M box layer and put that M box on the layer. Again, measurement box here. One would be width and interincial angle, and I want to have measurements in there and attached to +1, so they are here. And also this one should be put on M box. With silhouettes, I want to have them on the report as well. So I think that now everything is as it should be. I have measurement boxes, I have report, it should look like this. I have analysis. Okay, the last thing that I will do is I will add some tables and I will define reports. So a table, we'll put it here. With a double click, we can configure it. For example, this should not be a line, it should be transparent polygon. So this one, or we can choose polygon of a different color, blue. Okay, it's not very well seen, something like this. And I'm going to put it on table layer. So if table layer is switched on, you can see the table. If not, it's not seen. I'm going to save that and define the automatic reports. First automatic report would be report with measurement boxes. It should be a vector export without X-ray, with name and with scale defined, and I say OK. So we are done defining this analysis type, and I will use this analysis type in creating analysis. So change type, ZZ again, and run automatic tracing. Okay, what we can see here on the report is this. I can have measurement boxes switched on, I can have table switched on, I can make a print. So this is as expected what we did, and when I save that and go back to documents, I can notice the tracing and this report to be done. If I want some more reports, I can create other reports according to my wishes. I'd quickly like to show some more elements. So let's go back to analysis type, and I'm going to change the phantom, which can be one of phantoms for PA, then study model, and so on. So regarding those that modeling, if I place here a point, if I place here another point, and here another point, I can make a plane from here to here. Plane could be perpendicular through this of this one going through that point. It will be always perpendicular. I can make a point on cross section. I can take another plane, make an angle measurement, and if I want to split this one, what I do is make a split angle plane. It goes through that, and if I move that, you can see that that split angle will always be split. So if I double click, angle portion could be, for example, 10%, or can be 10%, or it can be a certain angle, for example 50 degrees, something like that. Or it can be a plane where a point is defined on a plane. For example, this point, if I move that point up and down, it will always be on the plane. With a double click, I have additional properties. It will be halfway from point, the beginning point to the end. And if I make this smaller, you can see that it is still at halfway, always halfway. And I can double click on a plane and make it run from the beginning to the end point without overlapping. So I have different tools here which can be used for modeling. I have arcs, I even have concentric arcs, distances, angles, functions, tabellaric values. So these all are tools that can be used for creating analysis type, and we can model virtually anything. At the end, I want to point out two key messages. AudaxCeph is a modern software designed entirely differently than other cephalometric solutions. The most important advantage of AudaxCeph, besides functionality such as automatic tracing, which really reduces time needed for tracing, in comparison to similar products, is that it solves one very big obstacle in cephalometry, which is you all use analysis types which are different from one to another. Speaking of this, AudaxCeph enables you to use an analysis type which is entirely in line with your wishes. So it is customized to your needs. There are some analysis types already prepared for instant use. I guess about 50 plus. You can use them and produce or modify an existing analysis type according to your needs by using cognitive geometry elements such as points, planes, measurements, calculated measurements, and so on. You may also use a library of almost 400 predefined measurements. You just pick the right ones and you are done. If you just want to change standard values with an existing analysis or add a measurement or two, it is a few minute work. And do not be afraid of doing something wrong. Everything is reversible. Also, if you experience too many challenges or lack of time to master the design, then we are here to help. I encourage you to talk to us. Please feel free to place questions in chat pane. And I will give the word now to Marco, because this concludes my webinar now, and I will join you in during the questions and answers session.